Let's do an example. Let's find the slope of the tangent to the graph of f of x equals the square root of x minus 1 at the following 2 points, 2, 1 and 1, 0. So this problem has two parts. So let's do first 2, 1. Okay, and here we need to always check that f of 2 equals 1, okay, because the problem may be incorrect. But if we check, f of 2 is the square root of 2 minus 1, that's 1, no problem. So let's go for it. Let me graph. We don't need this for the problem, but let me do it so that we get an idea what's going on. So this is the square root of x minus 1. Okay. And then at point 2, here x equals 2. This would be the point where we are working. And we have our tangent there. And we want to find that slope. Okay, the picture is not very accurate, but that would be 1. Okay, so we have learned that the slope of the tangent to the graph of a function is given by the derivative. So we need to find the derivative of f at 2. And by the definition is the limit as h to 0 of f of 2 plus h minus f of 2 divided by h. And now we just need to plug in all the information. Let me create some space. So this is the square root of 2 plus h minus 1 minus the square root of 2 divided by h. All right. So this is the limit as h goes to 0 of the square root of 1 plus h minus the square root of 2. Sorry, it's not the square root of 2, it's the square root of 2 minus 1 because that's the function. So let's correct that. And then the square root of 2 minus 1 is the square root of 1. So we might as well just write 1 here to keep it simple. And this is it. So this is the limit we need to compute. But if we try to just go ahead and do it, we get 0 divided by 0. So that means we need to be a little more careful there and apply some trick. And remember, when we have square roots, the trick we always try first is to multiply and divide by the conjugate. So it's the same expression, square root of 1 plus 8, but plus 1 instead of minus 1. And then because we multiply by that, we divide by that so that we didn't change the problem. Now this has the advantage that it's a sum times the difference. So this is 1 plus 8 minus, that's the square of the square root, minus the square of 1, which is 1. So those two go. Okay. And then we divide, oh, I'm forgetting. Okay, let's go back. You see that there was an 8 here that suddenly is not here. That means I forgot it. So we bring it back. And now everything is correct. I mean, the way I noticed is because here, in this type of problem, when you're computing a derivative, there has to be a cancellation always, every time, okay? And I was not seeing that cancellation happening. You see h with h. So I knew something was wrong. So that's something that can help when you are doing the problem. If there is any, you forgot something, you will know because suddenly it doesn't simplify. Okay, so this is 1 divided by square root of 1 plus 8 plus 1. All right, and then when h goes to 0, this is 1 divided by 1 plus 1, which is 2. So what we get is 1/2. So this is the slope at the point 2, 1 that we were given. Okay, so the tangent is going to look, it's always of the form mx plus b. Okay, or if you want, y minus y0 equals mx minus x0. So the tangent line is going to be y minus 1 equals 1/2 x minus 2, because we know the point was 2, 1. Okay, so this was not asked, but it's a possible extension of the problem. Okay, now 1, 0. We still need to do this point. So let's go ahead by the definition. The derivative of f at 1 is the limit as h goes to 0 of f of 1 plus h minus f of 1 divided by h. All right. So this is the limit as h tends to 0 of the square root of 1 plus h minus 1 minus the square root of 1 minus 1 divided by h. This is 0. So this is the limit as h to 0 of the square root of h divided by h. And there is a bit of simplification here, but not quite enough, you see. What we get, because h is the square of the square root, we can simplify 1 square root there. But what we get here, the limit is plus infinity. Okay, so no luck. Actually, this would be the limit from the right. From the left is not defined. Okay. So the tangent is undefined. Okay, what is happening here? Why is this so strange? Well, the function goes like this, and then the slope is vertical at the point 1, 0. Okay, so a vertical slope is an infinite slope. So that's what we are getting here. Okay, that's why we get this result. Now I leave for you. I leave for you to do the same we did at the point 5, 2. Okay, so you can do this example. It's basically, it's very similar to what we just did.